Hey, this is Alex from Tutors and Friends, and today we're looking at the focus and directrix of a parabola. And specifically, how do you write the equation that has to do with the focus and the directrix? And then how do you look at a graph and analyze these components? So let's start off here by just defining what these things are. The focus is a point that is equidistant from any point on the parabola when compared to the directrix. And I know that that's a mouthful, but basically all it is if you look at this diagram here, we've got our vertex, which is our little green point. Above that, we've got our focus, and then below that, we've got our directrix. And why are the focus and the directrix even important? Well, because any coordinate point on that parabola is going to be the exact same distance from the focus as it is from the directrix. Okay, so that's the defining feature here. You can see the little lines I've drawn in black. They both have one red dash through them, indicating that they're the same length. So this point right here is the same distance from the focus as it is from the directrix. Okay, and when you're graphing parabolas, they don't just have to be facing up like this. They can also be facing down, and you're gonna see today they can also be facing right or left. Okay, and the equation of the parabola will change depending on its orientation. So taking a look here, we've got some standard equations of parabolas whose vertices are at the origin. So when the vertex is at the origin, we can model an upwards parabola with the equation 1 over 4p x squared, where p represents the distance from the vertex to the focus or from the vertex to the directrix. And remember, it's going to be the same value because they're the same distance, right? Now, if the parabola is facing down, that p-value becomes negative. So it would be y equals negative 1/4 p x squared. And here's the thing I just mentioned. They can also be facing left or right if you look at these two equations down here. And how does that change the equation? Well, rather than having a y equals, we now have an x equals 1/4 p y squared. And if it's facing right, it's positive. If it's facing left, you're going to have a negative value for p. Okay? So let's take a look at our first example here. This wants us to use the distance formula to write an equation of the parabola. Wow. Okay, that seems a little complex, but I'll show you it's really not that bad. So first of all, what is the distance formula? Let's write that down. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula, something you learned a while back. It's based on Pythagorean's theorem. And I don't know if you remember, but our distance from this point P right here to the focus here is exactly the same distance as from that point P to our directrix here. Okay, so what that means is if we find the distance here, we can set it equal to the distance here. And you'll see how that helps us uncover the equation of the parabola. So let's start by looking at our first distance d here. So here's our x2, our y2, here's our x1 and our y1. And I'll just plug those into my equation. So I've got my first d is equal to the square root of x2 minus x1 would be 0 minus x squared plus y2 minus y1 would be 1 minus y squared. Okay, and I'll just clean that up a little bit. That would be the square root of x squared plus 1 minus y squared. All right, excellent. Now I'll look at my second distance here, and I'll do it in a different color, d. So my distance there would be, let's define my x2 and my y2. These are now my x2 and my y2. D would be the square root of x minus x squared plus negative 1 minus y squared, which if I simplify that, that's just 0 squared plus the square root of negative 1 minus y squared, which is just negative 1 minus y. And now I can go ahead and set these two equations equal to each other because we know that the distances are equal. So we can say that the square root of x squared plus 1 minus y squared is equal to negative 1 minus y. I'll square both sides to get rid of this square root. And that gives me x squared plus 1 minus y squared is equal to negative 1 minus y quantity squared, which is 1 plus 2y plus y squared. Okay? And then I'll just start simplifying everything. On the left, I'll have x squared plus 1 minus 2y plus y squared equals 1 plus 2y plus y squared. Subtract y squared from both sides, those cancel out. Subtract 1 from both sides, those cancel out. Then I'll have x squared minus 2y is equal to 2y. Add 2y to both sides, I get x squared equals 4y. Divide both sides by 4, I get y equals 1 over 4x squared. There's my equation there. And now, if you remember our original equation, which was y equals 1 over 4p x squared, that's the general form, where p represents the distance from the vertex to the focus or from the vertex to the directrix. We can see here that our p-value must be 1 because 1 times 4 is 4, so that's how you get 1/4 x squared. And if you look at it, it makes perfect sense because our vertex is right here at 0, 0. And then 1 unit up from that, which would be p, is 0, 1, where the focus is. And then 1 unit down from that, which would also be p, is y equals negative 1, which is the directrix. All right. Now, what if the vertex is not at the origin, right? So what if the vertex isn't 0, 0, it's somewhere else on the graph? And that's going to be something you commonly see, right? Our vertices are often not at 0, 0. Well, I don't know if you remember before, but we have our friends h and k back in the mix, where h represents the x value of the vertex and k represents the y value of the vertex. Notice we still have that 1 over 4p in front, where p represents the distance from the vertex to the focus and from the vertex to the directrix. Okay, so our vertex is at h comma k in this form. Our focus is at h comma k plus p, so whatever the y value of the vertex is, you just add p to that to get to the focus. And the directrix is y equals whatever the y value is of the vertex minus p. Okay, excellent. So let's do a quick little example here. I've got the equation y equals negative 1/8 times x plus 2 quantity squared minus 3. So for this, we can see that our p-value is equal to negative 2. How did I know that? Because this 1/4 p, let's solve that really quick. 1 over 4p is equal to negative 1 over 8, which means I can say that 4p is equal to negative 8, or that p is equal to negative 2. Okay, so what does that tell me about this particular parabola? It tells me that this parabola is facing downward. The question doesn't ask that, but it's a good thing to know that. Great, my vertex would be at negative 2 comma negative 3. How did I know that? Well, it's just the h value is negative 2 minus a negative 2, which is why it's a plus inside. And my k value is negative 3, which is out here. My focus would be at the same x value, so negative 2. But now, that's why it's really important to know this is facing down. My focus is going to be right about here, which would be p down from the vertex. So I take the y value of my vertex, which is negative 3, and I would subtract my p value, which in this case is 2. So negative 3 minus 2 is negative 5, okay? If it had been facing up, I would have gone from the y value of my vertex up to the focus, okay? But because it's facing down, I go down to the focus. All right, and then my directrix is y equals whatever the y value is of the vertex plus the p value in this case. So y equals negative 1. All right, great. And here are my general forms of my equation when my vertex is not at 0, 0. Something I want you to note is that when the parabola is facing left or right, inside the parentheses with y is k, y minus k squared, and then h is outside the parentheses, which is different from this equation, right? We have h inside the parentheses, k outside. With this one, when it's facing left or right, we have k inside and h outside. How are you going to remember that? Well, we know that y is associated with k, and so when it's left or right, those two things are together inside the parentheses. All right. We've got an example here. Identify the focus, directrix, and axis of symmetry, and then graph. Okay, cool. So first thing that I notice about this is it's a y squared equation, which tells me what? It tells me that our parabola is either facing left or it's facing right. Okay, it's not facing up or down. That would be an x squared. So first thing I want to do is get x by itself. So I'll rearrange this to be x equals 1 over 16 y squared. Now I notice there is no h or k involved here. So it's just a vertex at 0, 0. So it doesn't ask the vertex, but let's define that because it'll help. We know our vertex is at 0, 0. And then what's our p-value? Well, all I have to do is say that 1 over 16 is equal to 1 over 4p, or that 16 is equal to 4p, or that p equals 4. So I know my p-value is 4, and since it's a positive p-value, that means my parabola is facing right. So my focus is going to be p units to the right of my x value of my vertex. So that means I would just add 4 to the x value of my vertex, and that would give me my focus coordinates. Okay, so my focus coordinates would be, let's write focus, would be 4, 0, because we just defined that p was equal to 4, and then we just take our vertex, our x value of it, and add 4 to it, add p to it. Great, my directrix is, here's my vertex, here's my focus. My directrix is going to be p units behind my vertex. So all I would do is I would subtract p from my x value of my vertex. And remember, my directrix is, in this case, since it's facing left to right, it's going to be an x equals equation. So it's x equals -4. Okay, x equals -4. All right, now we need to graph this. So let's use these coordinates right here. We know that we have a vertex at 0, 0. We know that we have a focus at 1, 2, 3, 4, 0. And we know that we have a directrix at 1, 2, 3, -4, like that. Okay. So, doing a rough sketch, I can just say it kind of looks like that. But if I want to get a little bit more accurate than a rough sketch, what can I do? I can make a table of values. Okay, so I'll make a table of values, y and x. For y, I'll go ahead and choose 2, 1, and then -1, -2. When when y is 2, I'll have 1 over 16 times 2 squared, which is 1 over 16 times 4, which is 1/4. So I'll go ahead and plot that. When y is 2, x is 1/4. Let's pick some better values for my table because this is going to be hard to graph, right? This is a good thing. Let's pick some values that are going to give me something easier to see. Okay, so let's pick something like, I don't know, y equals 4. Okay, y equals 3, y equals -3, and -4. So when y is 4, let's find x. 1 over 16 times 4 squared is equal to 1 over 16 times 16, which is just 1. Okay, that's easier to plot. When x is 3, I'll have 3 squared, which is 9. 9 times 1 over 16 is just 9/16. Okay, and I don't know if you remember from before, but there's a symmetry about this, which, by the way, it asks us for. The axis of symmetry would simply be the y value of the vertex. So the axis of symmetry here would just be y equals 0. And I'll show you that when we plot the graph. When x is -1, or sorry, when y is -4, we get +1 again for x. Okay, let's plot these points now. So up 4, 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Up 3, 9/16. Down 3, 9/16. There you go, there's our better defined graph. Okay, and our axis of symmetry is right here in the middle, which is just the equation y equals 0. It's just on the x-axis, basically. Okay, cool. Great, good job on that. Next example wants us to write an equation for the graph. Okay, so now we've got something that the vertex is not at the origin, so we know h and k are going to be involved. Additionally, we know that this is facing left, so this is going to be a y² equation. And when it's facing left, that means p is less than 0, so a negative p value. So let's write our general equation just to start us off. It'll be x equals 1 over 4p times y minus k squared plus h, where we know that p is going to be less than 0 because it's facing left. Okay, great. So let's go ahead and figure out what our p value is first, because that's a simpler thing to do. So p is going to be whatever this distance is right here, and that's all we can figure out because we don't know where the directrix is. So whatever that distance is, let's see. So if it's 1, 2, 3, 4, 5, 6 points over to -12, that means that each unit is 2. So the distance from the focus to the vertex would be 4. Okay, so p would be equal to -4 in this case. Great. Let's figure out what the equation of our vertex is. So our vertex is at -2, -4, 0. Excellent. So what is our k value? Our k is equal to 0, and our h is equal to -4. Great. So we've got everything we need to fill in this equation. Let's do it now. We know x is equal to 1 over 4 times -4 times y minus 0 squared minus 4. Just simplifying that, I get x equals -1 over 16, y squared minus 4. There's my equation there. All right. And just for good measure, we'll do one more. Let's take the equation y is equal to 1 over 8 x minus 2 squared plus 3, and let's graph this. Okay, let me make a set of coordinates here. All right, so first thing I notice is this is an x² equation, meaning it's going to be facing up or down. Since p is positive, that means it's going to be facing up. Now let's figure out what our vertex is. So our vertex, since this is an h, k equation, would be 2, 3. The 2 comes from right here, the -2, and the 3 comes right here. What's our p value? Well, we know that 1 over 8 is equal to 1 over 4p, or that 8 is equal to 4p, or that p is equal to 2. So our p value is equal to 2, which means that if we do a quick little sketch of what this might look like, boom. If our vertex is here, that means our focus is here, which would be p units up from the vertex. So we would just take whatever the x value of the vertex is, add p to it, and keep the k value, and that would be the equation of our focus, right? So let's try that now. So focus would be 2 plus 2, 3. It's just the x value of the vertex plus the p value, whatever the y value of the vertex was. So I can simplify that. 2 plus 2 is 4. So focus is at 4, 3. Great. Let's get rid of this sketch. That was just for explanation. Let's do our directrix. What's our directrix? Okay, so actually let's put that sketch back. If this is our vertex, our directrix is just p units below the vertex. So all I would do for the directrix is it would be y equals whatever the y value of the vertex is minus p. Okay, so it's y equals 1. That's the equation of my directrix. Y equals 1. All right, so now we can start graphing our parabola. All right, so let's do our vertex first. Our vertex is at over 2, up 1, 2, 3. Our focus is at over... Oh, I messed something up on the focus. Great, good. This is excellent. I'm showing you now. So if my focus was at 1, 2, 3, 4, comma 3, that wouldn't make any sense. That would mean my parabola was facing right. But this is an x squared equation. So what did I do? Instead of adding 2 to my x value of my vertex, I should have added 2 to the y value of my vertex. So because p is 2, it would be 2, comma 5. Okay, so my focus is actually at 2, comma 5 right there. And how did I know that? Because it has to be facing up. So my focus has to be in this orientation. If it was the other way, it would have been facing right. So you can check yourself by looking for those types of things. And my directrix is y equals 1, which is right here. Okay. I'm going to make a quick table just to get a couple more values. Let's do when x is 1, 2, 3, 4, and when x is 0. When x is 4, I get 4 minus 2, which is 2 squared is 4. 1/8 times 4 is 1/2. 1/2 plus 3 is 3.5. When x is 0, I get the same thing. Okay, so I'll plot those 2 points. 1, 2, 3, 4, comma 1, 2, 3 and a half, and then 0, 3 and a half. Boom. There you go. And that's just another way to write the equation of a parabola using the focus and the directrix.